All right. Please welcome Santosh Panda, Advances in Geospatial Data Science and Applications.
Thank you, Carl. So it's still morning. Good morning, everybody. Okay, so a little bit about myself. I am a graduate from UAF, and I worked at the GI for several years after I graduated. I was a graduate student at the GI. And then about 5 years ago, I moved to Natural Resource and Environment program. I'm faculty there. I teach the GIS and remote sensing classes, 2 undergraduate classes, 2 graduate classes. Along with that, I have several open access courses on edX. Alaska X is a partner of edX, and we have probably 50 plus courses now on Alaska X program. Out of that, probably 10 or so are geospatial focused. And so I have several courses on there. If you're interested in learning GIS, it's an excellent resource. Right now my research is completely focused on forest. In the past, I did research on frozen ground and permafrost. So we'll talk about geospatial data science, but before that, what is data science? So we hear this term data science quite a bit, and along with that, we also hear the term like big data, data analytics, machine learning. Okay, and if you're interested in what is happening to this term, then there is a Google Trend Tracker, and you could probably, so this is the site. And so this one, you can, since 2004, they have been sort of keeping track of what is happening to these different terms. The blue one is data science, big one is big data, data analytics, and machine learning. And what you're seeing is that there's quite a bit of jump in both use of data science and machine learning in pretty much since 2016 and so, okay? But also this one shows not only the overall search of these terms on Google search engine, but also breaks it down by region as well. What is the dominant term that being searched from different parts of the country? Looks like for Alaska, it is data science. For some of the states, it is machine learning and so on. And you can also even break it down by, how many people are looking for data science masters, data science, salary, all those, the terms that people are using to search, okay? This is a fun kind of trend tracker if you want to explore it. Okay, so from a high level perspective, data science is science of data, okay? Or study of data, nothing different. But from a disciplinary perspective, it is a interdisciplinary field that uses methods, processes, algorithms, systems to extract knowledge and insight from both noisy, structured, and unstructured data set, and something that enables us to take actions, okay? So we take the knowledge and insight from data science, and we apply it across a broad range of disciplines. It's not specific to any particular domain, okay? Then what is geospatial data science? Well, when you have a geospatial component to the data, then we're kind of talking about geospatial data science. It brings forth the theories, concepts, and applications of geographic data in the realm of data science. One example would be NOAA's forecast of different weather pattern, including like hurricane, but they're using a variety of data set. They're using satellite data, they're using weather data, they're using climate models to, along with, all this data going into statistical modeling, machine learning to give prediction about, how a particular event is evolving. Okay, so I will focus on 3 advances in geospatial data science, and then I want to share 2 applications related to GDS. So one is that increased access to real-time or near real-time global scale data sets, okay? And I'll spend more time going through this topic. Next one is access to cloud computing, okay? Cloud computing through some major providers like Google, Amazon, Microsoft. And then I'll talk a little bit about the Geo AI, which is the integration of AI and geospatial. So pretty much AI algorithms being available through the geospatial software. So now we can actually use AI algorithms for image processing as well as vector data processing. And then I will talk about a few case studies. So first, whenever we are facing any time-sensitive decision, it is really important to have real-time data. And the ability to collect and analyze data in real time has brought the GDS to a whole new level, okay? Because this was not the case. I started doing geospatial 20 years ago, exactly, 2005. And back then, if you want to do anything geospatial, then data were available in different platforms. You have to go spend time looking for the data. And then once you find the right data, you have to download it to your computer. And then only you can do something with it, okay? So that was a kind of a long process. There was always a lot of lag between data availability and creating something with this data. But the whole thing has changed now about close to 10 years ago with the cloud storage and cloud computing. So now there is no need to move data at all. Data stays where it needs to at one place, but you bring your code to the data, okay? And you can access the whole catalog. So for example, Landsat is one of the longest running satellite record in the world. It started in 1972, so it has 50 plus years of global observation, okay? And 26 for each location. So you can imagine we're talking about tens of millions of scenes. And you can now have access to all that without having to download any of it to your local computer, okay? Here, in this presentation, I'll share that with, share the presentation PDF with Carl. I provided a lot of links that has videos, links to the blogs, some notebooks. And so there's plenty of material that will keep you busy for months. So feel free to explore it on your own time. I just want to highlight this particular page here. This one talks about the access of Landsat data on the cloud. Okay, this is the USGS page. And there are some interesting videos on it, but also they provide a lot of guides about how to access it, okay? And again, some really interesting, fun videos to watch. So you can now find all public data in a variety of platforms. I'll just name the three major ones: Google Data Catalog, Microsoft, and Amazon. So Google one, this one, if you just, again, we have the link here, but if you go here, Earth Engine Data Catalog, you can find not only like local scale, but global scale data products. So climate and weather, atmosphere, imagery, all kinds of, okay? And these are all publicly available. You don't have to pay to kind of access any of this data set that is sitting on this catalog. And so we're talking about 1,000+ data products that can, probably in hundreds of petabytes of storage, okay? And I'll use access some of it during my demo today. I have a demo in plan. So similarly, Microsoft also has a data catalog of their own. Here you can also see things grouped as feature data set, air quality, biodiversity, and so on. And again, you can access all of those data set without really needing any sort of storage space or computing power, because you can access cloud computing through just a browser. Some of the key building blocks of geospatial data science: data integration. As I said, data can be available at multiple platforms, multiple sites, multiple formats: vector, raster, within raster also very different file formats. So data integration is one of the important block of geospatial data science. You have to bring the data in one place. And when I say bring the data in one place, I'm saying you have to access the data, not really needing to download the data. Data exploration, every time you are accessing a data set, first thing you want to do is try to learn as much as possible about the data, its properties, its limitations, who collected it, when it was collected, and so on, okay? Spatial analysis is the traditional geospatial analysis that we have been doing for 50 years now. But along with that, we also have Geo AI, which is the integration of AI algorithm within the geospatial software packages, okay? Big data and scripting, whenever you are dealing with massive amount of data, you have no choice but to use scripting and programming, okay? It is really extremely difficult and time consuming to manually process big data sets, okay? So scripting is a big part of geospatial data science. And then of course, sharing and collaboration. So now you have various ways that you can share your work, not only the results, but also the workflow that you produce through notebooks is pretty much same as like sharing a Google Doc, and others can very easily replicate what you have done, because data is sitting openly in a public platform or in a platform that is accessible, and then you have the code that can actually do all the things that you need to do. So it's really pretty easy to replicate others' work if they have shared that through a notebook or through GitHub. Okay. So what is cloud computing then? We have been talking about. Oh, I'm still going. Okay, full screen. Yes. So what is cloud computing? Cloud computing is using IT resources that is sitting somewhere else, okay, via internet. And so what that means is that you can just simply have just a computer that can only do browsing. That's it. Because you will do all the computing work on a server that is sitting somewhere else. Okay, so that's what cloud computing is. And so I'm going to spend a little bit of time on Google Earth Engine. I have a demo prepared, so I'm going to be. So what is Google Earth Engine? Again, some of you already know about it. Is it's a cloud computing platform, but along with that, it also provides you thousands of data sets. That's like hundreds of petabytes of data, and to do a variety of things, detect change, map trend, look at what has been changed on the surface. Not only on the data, but also you can use products. So I have some demo, when you can look at a product that was produced maybe 20 years ago and a product that was produced just recently, and compare what has changed on the ground. If you want to learn Google Earth Engine, then there are two, again, free resources out there. Well, no, it's not. Second one is not free. The first one is a online tutorial series that was put together by I think probably 40 plus scientists, and that one is JavaScript based. The other one is a book that came out earlier this year by Kushan Wu. And so this one is, you can do the same thing, but using Python, using Jupyter Notebook environment, okay? Excellent resources if you want to learn about Earth Engine. Okay, so I do have let's see, how many of you are using Colab here? So it looks like almost half of people are using Colab. Okay, but not the other half are not. So let me just play this video a little bit. We don't have to watch the whole thing. It's a 3-minute, but maybe 1.5 minute into it, and then I have a notebook that I want to use. So it only makes sense if you kind of know a little bit about the Colab. So let's see. Yeah, so this is a video, and I will play only a minute and a half. I think I'm going to stop here. And again, I have a link if you want to get started in Google Colab. Also, I have a notebook that I want to use to demo a few things. So I have the notebook. Let's see. So I have the notebook here. And, again, you can have text explaining what is happening in the notebook so that, when you share it with somebody else, they understand and they can follow along. And so what we're doing here is that we already have a PyGIS install. And the other thing that I want to highlight is that the video didn't. So when you start a Colab notebook, we are actually starting a cloud computer, okay? And if you go to the right here and then look at, let's see, view resources, it is actually giving you a computer that has about 13 gigabytes of RAM and about 110 gigabytes of storage, okay? So you are actually running a cloud computer. So, and you can run multiple instances of Colab and at the same time, and each is a separate computer. And so when you're starting, you do have to, whatever you need to do, like the packages, the programs that you need, you have to install that. It does come pre-installed with a lot of the Python, the traditional Python packages, but if you're using something outside of that, you have to install it. In this case, we're already installed PyGIS. We are calling some libraries because we want to use Earth Engine. And you need to have an Earth Engine account. So that requires that you first apply for an account. And as long as you have a Gmail, you can apply. And it might take a few days to get an approval. But once you have it approved, you should be able to access it. And once you have that going, just through simple clicks, like this is one line of code to create an interactive map that is showing you, kind of giving you a canvas where you can bring in your data and visualize your data and do some fun work in here, okay? So I have a few different things that I want to show. Let's see. So again, by default, it comes with the OpenStreetMap, but you can actually add something else to it. You can add a high resolution image to it and zoom in, and it can explode. This is one of the latest high resolution based image that is available. On top of that, you can bring in some actual data set. So for example, let's see if we can bring in some data set to it. So this one is, again, I'll take you to the Earth Engine catalog, but by using, again, one line of code, we are accessing a data set that is sitting in the Earth Engine catalog, okay? And this one is a SRTM digital elevation model. So that has elevation values for cells, okay, at 30 meters. So, but this is a global product. So if you want to go back to the Earth Engine data catalog in the search box, if you say, elevation or SRTM, then it'll pull up all the data set that has SRTM tagged, okay? And this is the product that we are talking about. So, you can find everything about this product before you use it. There's a description, how many bands in it. This is a digital elevation model, so it has only one band. And then it can tell you the min value and max value. The max value is 6,500. And then what is the ID for this data set? Okay, that's the ID for the data set, okay? And so now you can see that it's the same thing that we are doing here, e.image, to read this particular product, okay? And we can now display it, okay? So we read that elevation product, and it can tell us everything about its properties. It has 24 different properties on it. And now let's bring that data to our interactive map, okay? And so we are now going to bring this same DEM product to the interactive map. Okay, so now we have this DEM product now being shown on this map, interactive map, and you can zoom in and zoom out. As I said, it's a global product, okay? And so you can zoom into any area that you're interested in. And you can also inspect the cell values, okay? So you can go, there's different control. Here is the zoom control. Here is the control where you can draw polygons, lines to make measurements. You can also draw a box and say that I am only interested in data set within that box. Also, it has something called an inspector tool. So you can click on this inspector tool and you can click on a location and it will give you the elevation value for that, which is 1,610, 191. These are, I believe these are in meters. So you can inspect your data set. Not only that, means you have a lot more going here. A lot of things. You can create time lapse if you're dealing with time series data set and you want to look at one location. So we'll create some time lapse as well. But also here is the data tab here. And remember how I kind of looked for the SRTM data in the Earth Engine data catalog? You can actually search data within that interactive map environment too. So you click on data, and then you say, okay, I'm looking for SRTM products, okay? And then you press enter, and it is going to list all the SRTM product that is sitting on the Earth Engine data catalog, okay? And then you grab whichever one you want to use, and then let's see, SRTM. We can click on this one. And then if you want to say, you want to bring this data set to your map, then it also gives you the code. So this is the code you can use to sort of bring this data set, copy it, put it in a cell like the video showed. You can click here and add a cell, and then you can just copy paste, and then you're able to access this data set. Okay, and that's about it. So this one is using the version 4 of the DM, SRTM DM, and then it is reading the elevation. And then it is actually creating a slope out of it, okay? And it's going to show the slope values. So let's do that. So now, before we had the digital elevation model with the cell values only, we use that to create a slope map. So now what you have in this one is the slope values for each cell, okay? So now if I click anywhere using the inspector tool, I have 2 layers. So you can, again, I have the DM layer and I have the slope layer. So now if I can, if I click using the inspector tool, I can see the values for 2 different things. So I should be able to see the value for what is the elevation value and what is the slope value, okay? And white means steeper terrain, okay? So this should have a higher slope, close to 59 degrees, okay? That's good. And then let's see, what else we want to see. So maybe some of the fun thing would be to, again, so you have access to this notebook. Once you have the slides, you can access this notebook. And as long as you have an Earth Engine account, you can pretty much go through this whole notebook, which is a lot of things. So this is a kind of a short course on how to use Earth Engine, okay? And I want to do something interesting. Let's see, we have a split window. Okay, split panel map. So let's look at this. So I talked about, comparing things, right? So you can do that. You can use, you can have 2 split windows and bring in 2 different products and compare. So let's see if we can. So here what I have going is, in this one, we're comparing something called NLCD, which is National Land Cover Data Set that provides land cover for the whole country. And, in the past, this product will come out every 5 years, okay? And things have changed, and we'll talk about that later. But in the past, you'd have, and so here, what you're doing is that we're actually comparing the 2001 NLCD with 2019, okay? And I'm zoomed into the Great Salt Lake, and we're comparing what that lake looks like. This is 2001, and this is 2019, okay? So you can do things like that, but also you can even do more stuff, So let me see if I can. So this one, here you're not only able to, so you can actually pick. We're able to load all of them in the 2 panels. So all the NLCD product, 2001, 4, 6, 8, 11, okay? And now we can compare. We can pick which one we want to use. We want to use 2004, and on the right panel, we can pick another one, maybe 2016, and then we can do this comparison. So now we're comparing 2004 versus 2016, okay? And so we're comparing a product, but of course you can generate product as well, okay? Another thing that I want to quickly demo is creating time lapse. So this would probably be fun for people. So you can create time lapses, okay? And so let's see, create time lapse. So we're going to focus on a particular region. Actually, I have 3 different ones. I have one for, this is a region in Peru, and then I have one for Las Vegas. So yeah, let's do this one, okay? So we're going to create a time lapse, again, in a few lines of code, but you're able to access the whole catalog of data. And in this case, we are accessing data from 84 to 2022. Okay, so we're using data from 84 to 2022, and we want to create a time lapse based on that. So let's run that. I need to run something before that. So I need to give this bounding box. And so this is now centered at Las Vegas. And now let's run this one. So now it's generating a GIF, which is kind of animation. So it may take, let's see, a minute or less. And every time you run a cell, it does tell you, how long it took to run the cell. Okay, so this time will update once it's ends running. Okay, so now it produced a GIF for us, which is using data from 1984 to 2022 and showing, how that landscape has changed through time. Okay. And not only that, you also have this GIF is available for download so that you can put it in a presentation. So if you, as I said, the Colab notebook is a computer, and so you have a storage. So you see it actually, that file is being saved here as a GIF, and of course you can go and you can say I want to download this file, and you download that GIF file, and then you can install it. You can put it in any computer. In presentation or document. Okay. Let's see, anything else that would be interesting. And then there is one also on the surface water. Okay, so let's look at this one. So you can, again, there is a product called Global Surface Water Extend, and in the catalog, so you can access that whole product. Okay, it has 7 different properties or information. One is the presence of water, presence or absence, and you could actually pretty much load that data set, and it's you can zoom into one location of interest, or you can so we just kind of edit a map here, and then here we're going to be saying that we want to create this or kind of add this water product, okay, surface water extend product. So now this is being added, and you can, again, zoom into any area of interest, and what you'll find is that all the surface water is mapped in this product, okay? So this is just visualization, but also you can export your data as a CSV file, and you can create plots as well, histograms and things like that. So here we are kind of exporting this as a data frame, and then you can export it as a CSV file, and you can create histograms, okay? So something similar to this one. And so this one is telling you how many water bodies with this pixel count. So we have several big water bodies, with few thousand, several tens of thousand pixel count. Okay, so I'll kind of stop here. Again, you have access to this notebook through the presentation, and you should be able to kind of use it. And also you can change the area of interest and see if you want to create something for your study area. Next, I'm going to talk a little bit about the integration of AI with the geospatial. Again, what is AI? AI is a kind of a big term. It pretty much encompasses anything where we are trying to mimic what what human can do. Okay, and so you have different categories of AI. You have weak AI, you have general AI, you have deep AI, and within this AI, one particular subdiscipline that we geospatial scientists use quite a bit is called deep learning. I do have a video. I'm not sure if we have time to play, but and what time we end, Carl?
You end, but we have to walk out of here at 12:45.
12:45. Okay. We do have a little bit of time. So I want to play this deep learning one a little bit again. I'm not going to play the whole 3 minutes, just maybe a minute and a half, because I think it's relevant to the kind of work that we are doing. Okay, so that was deep learning kind of in a nutshell. And so we are using quite a bit of deep learning algorithm in geospatial science now, and this is becoming more in the different models. So for example, somebody's interested in mapping a swimming pool. Somebody's interested in mapping tree canopies, or somebody's interested in mapping all the roads. So for a lot of these kind of image detection tasks, deep learning can perform much better than a lot of the traditional algorithms that we have used in the past. So each link has kind of quite a bit of resources, some videos, some blogs, and so on. So there's also a notebook related to SAM. Facebook came out with this particular algorithm that you can apply on any image, and it will kind of break the image into different segments. And you can keep the one that you want to keep, and you can remove the one. So it's pretty much same like what you do to edit people or things out of your image, okay, photos. So now I'm going to talk a little bit about applications. So one application that I want to share is called Dynamic Wall Near Real-Time 10-meter land use land cover product. So as kind of I mentioned earlier that before we had products land cover land use, but a lot of the time the product would come out every 5 years or 10 years, or it would be only for a specific part of the work. And there was a lag, easily, several years of lag between the data when the data was available and the data set was the product was produced. Okay, so that whole thing changed with dynamic wall product, and so which is first of its kind near real time LULC product that uses deep learning and Sentinel-2 imagery. Okay, so Sentinel-2 is from European Space Agency, and it's again openly available at the global scale. And since we are using the cloud computing, or this particular product is using the cloud-based system, as soon as the data is available, a scene is acquired, it is fed into the system, and the system will predict the land cover, and then the product is available for users like us. Okay, so it has really changed the overall usage of not only Sentinel data, but also helping people in variety of discipline, because our land cover never stays the same. And so what we are looking here is that this particular plot is showing that this is winter, but then the green line is for the tree canopy. And so as soon as the spring comes, the trees started kind of the leaf starts coming out, and then we reach the full canopy. Winter, we have a lot of snow, but with time, snow is gone, and then no snow during the summer. So our land cover is always dynamic, and so now one can use this kind of product to study, to analyze process that's changed through time. Okay. Another one that came out from my group is on-demand production of hyperspectral imagery. Sorry, hyperspectral imagery using multispectral data. So multispectral Sentinel is called a multispectral because it has only a few bands, like about 13 bands. And we have another data product or kind of remote sensing data called hyperspectral that can have hundreds of bands. Okay, and so the plot here is comparing the multispectral Sentinel-2 bands, which is kind of this yellowish bar, and then we have the wavelength in the x-axis and reflectance on the y-axis. We're comparing that with the continuous curve for the hyperspectral or spectral profile from a hyperspectral data set. So what you're seeing is that the hyperspectral data is way more spectrally rich. And so what that does is that helps us detect things more accurately from image, okay? And so one can actually, so the product on the left is a land cover or vegetation product. And so this one is derived from Landsat data, and this is 30 meters. So a product that looks like this with sort of poor accuracy can be converted into something like this, which allows us to see many more different kinds of vegetation, but also with much better accuracy. So again, this is again another example of geospatial data science, where you can take a poor resolution, spectrally poor data, create a spectrally rich data set, and then use that data set for your mapping. So there is a story map in ArcGIS story map that can tell you everything about that particular product, but we also have a built-in app, okay? And so this is again, this is also based on Earth Engine, and this is only for Alaska. We produced it, and so you can, for any parts of Alaska, you can zoom in and you can just draw a polygon. And as soon as you draw a polygon on this app, after that, you can come to the select value, and this is telling me the scenes that are available for this area. You can pick a scene, and then as soon as you pick the scene, it started actually creating the hyperspectral image cube for that area. This is mostly for a demo, so it only does it for 1 kilometer. Otherwise, it can overrun the system. And not only that, you can also download this. But what is more helpful is that you have access to the code. So you can click on the access code, then you can access the code, and then you can sort of tweak this code to make it work for your area of interest, as well as you do the same thing for a much larger area. Okay, so you can do that within Earth Engine, but also if you have data sitting somewhere else, you can access the data from that source, and you should be able to generate hyperspectral image cube for your area of interest. Okay. Esri, ArcGIS Pro also, and as I said, pretty much all the major geospatial software products, they started integrating AI tools in them. And so Esri is also has a lot of different deep learning models, which is part of their package. You do need to install it on top of the standard ArcGIS Pro installation. So here I'm giving you the link where you can learn more about the deep learning package from Esri. And then here is you can access the deep learning package and install it on Arc Pro. So you need to have Arc Pro first. And there are a lot of courses and tutorials that are out there that you can use to learn how to kind of use some of the deep learning models within ArcGIS Pro. Okay. With that, I just wanted to summarize that cloud-hosted geospatial data has reshaped how we have been using geospatial data science and its impact on society. Cloud computing enables the processing of large complex data set, which was just not possible, and helps us derive greater insights that can be used to take actions. GeoAI is still it's a emerging field, it's still evolving, but it's poised to become a major force in GDS and impact our daily life. But also we also have now a lot of open access, ready to use tool for both enhancing our research as well as teaching. Okay, so with that I will end, and then more links and more resources if you want to learn more about deep learning and geospatial data science. And then I would like to conclude here, and I'm happy to take questions.